Hi, that's the first lecture for complex roots in Z transform. We're trying to understand these two transformations so we'll be able to find the inverse of Z transform for the case when the roots of the denominator are complex. And there are two types of the complex roots. So let's investigate the situation. If you go to the table Z transform, you'll find you will have cosine and sine function. If you have cosine and sine sequence and you check its Z transform, you'll observe that the denominators, A of Z, the same. Z squared minus 2Z cosine omega plus 1. Both are the same. The only difference between the cosine and the sine, the top part, the numerator, they are different. That's how to make it sine or cosine. Let's investigate what type of complex roots we get when you have sine or cosine only. Assume omega is equal pi over 3. So what's cosine omega? Cosine pi over 3. Well, in this case, you will have cosine omega, cosine pi of 3 will be equal to 0.5. And sine omega will be equal to 0.866. All right. Well, when you look at the magnitude is equal 1. Is equal 1. Cosine omega squared plus sine omega squared is equal 1. This is for any angle. All right, we know that rule. But I'd like, now to look for the denominator, AZ. Investigate it now. A of Z is equal Z squared minus 2Z. In this case, cosine omega is equal 0.5 and plus 1, which is equal to Z squared minus Z plus 1. Let's find the roots of this equation. You can find the roots of this equation using MATLAB or calculator. I'm going to use a MATLAB. I'll write roots 1 minus 1, 1. And I'll just run the program. I'll just do it right now. Roots 1 minus 1, 1. And enter. I found that the roots are 0.5 plus or minus j 0.866. So the denominator of this function, the roots of it, they are 0.5 plus or minus j 0.866 is the same as the cosine and the sine of the angle pi over 3. It means if you do that, if you say z minus 0.5 plus j 0.866 times z minus the other root, the conjugate 0.5 minus j 0.866, you are going to get z squared minus z plus 1. So when you have the roots of the polynomial complex and the magnitude is equal 1, also, that's very important. If you go and you square 0.5 square plus 0.866 square root, that's the magnitude. All right, call it A. It's equal 1. So now let's say that if you have any f of z and f of z expressed as b of z over a of z, and you find that the roots of a of z, the denominator, they are complex, like say x plus or minus j y. That's condition. The condition number 2, the magnitude of any root is equal 1. Result, that's very possible sine omega n un or cosine omega n un. Two possibilities, not third. if you have the roots of the denominator complex and the magnitude of any one of them is equal 1. It means you got sine or cosine. In this case, if you have these roots 0.5 plus or minus j 0.866, I can find for you this function. Let's find f of z. F of z for the cosine is equal z times z minus cosine omega. So f of z is equal z minus cosine omega and z square minus z plus 1. This is for the case if you have the roots x plus minus jy is equal 0.5 plus or minus j 0.866. Let's now substitute. You got z minus cosine omega, it's the value of x. Okay, which z minus 0.5. So you have, that's by the way, that's I'm talking about this part, the numerator a of z for the cosine. So you have z square minus 0.5z. And the numerator is the same. So I mean you have z square minus 0.5z over z square minus z plus 1. That's the function or the transform or z transform for the cosine omega. And you can get omega now. Just write omega n multiplied by the step function. This is cosine. If you want to find omega, very simple. Omega is equal 10 minus 1, if you have the roots, y over x. 10 minus 1, y is equal 0.866 or 5. And of course, you're going to get it the same value that you assume, pi over 3. You can find in decimals, okay? But I know that's equal pi over 3. All right? So how do you write the inverse of this one? Cosine and omega is equal pi over 3 n and the whole thing un. That will be your function. When you see it in this way. So the first thing, you check the denominator. If you find the roots are complex and the magnitude is equal 1, it's sine or cosine. And if you see that the top part equal to this part, as we show you the formula, this one, so you can directly find the inverse of it by substituting by the value of omega x. What about the sine? The sine should be like that. The bottom part should be the same, z squared minus z plus 1. And the top part, let's go look at the table, should be z sine omega. Z sine omega. Z sine omega. Sine omega is the imaginary part, which is 0.866 multiplied by 0.866. Let's write nicer way. So this is the way it's supposed to look at. That should be the sine. So the inverse of this one will be equal to sine omega, sine pi over, over 3, I think. Yes, n un. So when you have complex roots and the magnitude is equal 1, you can directly find the value of x, the value of y, the real and imaginary part, and if you put it in this formula, you have the table. So that's cosine. If this one will be sine. Sometimes it's a combination between sine and cosine, combination of them, both of them. So let's just have an interesting example. This is the function given in Z transform, and you look at it. The first thing you're supposed to do, find the roots. Maybe you have simple roots, repeated roots, you don't know if you are going to have. All right, so how you find the roots of this one? Using calculator or MATLAB? Well, so you will say that B of Z sorry, this is called A of Z, just to agree about it, this A of Z, and the top part B of Z. A of Z is equal Z square minus Z plus 1 equals 0. That's the step we're going to find. Then you solve this one, you'll find that Z could be equal to 0.5 plus J 0.866, or Z is equal 0.5 minus J 0.866. And now we check the magnitude of Z, 1. The result, the sequence must be sine and or cosine, maybe both. Okay, so what's supposed to do? Well, you already found the roots, so you can say that the real part x is equal 0.5 and the imaginary part is equal to 0.866. Now I want to look at the top part. Don't worry about it. Just go to the table and find the sine and the cosine. Look at the table and find the sine and the cosine. The cosine tell you Z times Z minus cosine omega. The top part. Just remind yourself, cosine, the top part is equal Z minus cosine omega. I'm talking about the top part. And you can write, you know the omega. You told me, no, I don't know omega. All right, find omega from here. How you find omega? You will just say omega is equal 10 minus 1 y over x. If you do it in the calculator or MATLAB, maybe you will not get perfect pi over 3, but it doesn't matter. Use the decimal. I'm going to do it now, just to put the real result using MATLAB. It's like calculate 0.866 divided by A10, 0.866 divided by 0.5. You see, I got 1.0472. All right, so that's the result. I know it's equal pi over 3, but you don't know. I mean, when you have values like that, you're not sure, you know. So it's okay, because you are going to get the real result. All right. Now you can write this one, Z minus cosine omega. What's cosine omega? Oh, well, cosine omega is x. Let's write that. That's cosine omega. So that's equal to Z square minus 0.5 Z. Please follow the steps that I'm going to do. Now, if this is cosine, what about if it's sine? If it's sine, the top part, just let me remind you that we're talking about only the top part, not the whole thing, because the bottom doesn't change. The denominator is the same for both. The top part for the sine is equal Z sine omega. Z and sine omega is y. This is sine omega. That will be equal to 0.866 Z. So that's the sine part. Just let's mark them. So this is the sine, and that's the cosine. All right. Now, well, that's what you have. The top part, what's given, that's what you have. 2z square plus 1 by 0.598z. So let me write. What we have, our A, I'm sorry, I always make a mistake with that. Our B, the top particle B of z is equal to 2z square plus 1.598z. So the question is, what is the relationship between the top part that I have in the problem, which is this one, and the cosine and the sine? Always assume the one in your hand is a combination of both. Sum of cosine and sum of sine and add them together. What do I mean by this? I mean, if you multiply that by alpha and multiply this by beta and you add them, you should get this one. You should, in general. So if you multiply alpha by the term of the corresponding cosine, you will have alpha times z squared minus 0.5z plus portion from sine beta times 0.866z. That should be equal, what do you have in your hand? 2z squared plus 1.598z. Now let's just simplify to find what's alpha, what's beta. So you have alpha z squared minus 0.5 alpha z plus 0.866 beta z equal to z squared plus 1.598z. And then collect like terms. You have z squared here, that's the only z squared, but this one part z and z, so collect z together. Alpha z squared plus 0.866 beta minus 0.5 alpha, the whole z, equal the other side. 2z squared plus 1.598z. And now you compare z squared with z squared. What you get? Alpha is equal to. Great. So you got 1. Well, beta, you go for the coefficient of z in both sides. So you have 0.866 beta minus 0.5 alpha equal 1.598. You want to find beta, so beta is equal 1.598, and move this part to the other side with plus 0.5 alpha, and you know alpha is equal to, and divided by 0.866. That would be equal to 2.59, because 0.5 times 2 is equal 1. You add 1 here. 2.598 divided by 0.866. I'm going to calculate it. See, I'm having MATLAB in front of me. I want to save your time. 98 divided by 0.866. I get 3. Even 3. All right. So now I have beta is equal 3. What does it mean? Remember, alpha is related to the cosine and beta to the sine. It means I got 2 of the cosine plus 3 of sine. So now my function or sequence f of n, just let's make a different color. So the function that in my hand now, it's equivalent to alpha is 2 times cosine omega n un plus 3 sine omega n un. I can take it compact, but now you have to put omega. You cannot leave it like that. How can you find omega? We got omega here. Omega when we divide the imaginary by the, we got 1.0472. 1.0472. So you write the function in this, the final form. 2 cosine 1.0472 n plus 3 sine 1.0472 n and all un. And that's the function or the sequence that you want to find as the inverse of Z transform. Make sure that you can find the value of this function or this sequence at any n. For example, you might be asked, find f3. Means at n equal 3, the fourth samples, what is the value of n? You just substitute. Remember, all this in radian. So you say f of 3 is equal to 2 cosine, and you multiply 3 here. 1.0472 times 3. You find the value in radian. You find this value of the cosine. Evaluate it. You can do it in the MATLAB. Sine 1.0472 times 3. Un, just to make sure that n should be greater than 0 equals 0. That's it. So now you should be able to find the inverse of z when you have a complex number, but there's condition. It's complex number and magnitude is equal 1. What does it mean magnitude is equal 1? It means you have just angle, because any angle, its magnitude is equal 1. This is your angle omega, and this is your x, and this is your y, and you have condition x squared plus y squared square root is equal 1. All right? You are like in the unit circuit. So that is the first case. Next lecture, I'm going to explain what happens if you have a complex number and the magnitude is not equal to 1. Till then, stay safe and see you soon.